Hi and welcome. Today we are going to be introducing you to the power rule and some basic differentiation techniques. So first things first, what is differentiation? Differentiation is basically just saying we want to find the gradients of any points in a graph. So let's say we want to find the gradients of the graph at this point, for example. How could we calculate how steep this line that just touches this point be? Well, let's find out. The first rule is going to be the power rule. This states that if we have the derivative with respect to x of x to the n, this is going to be equal to n times x to the n minus 1 power. Okay, so what does this mean? Well, you can kind of think of it as I'm going to bring the power down and I'm going to duplicate that power and subtract 1. Let's try a few examples. Let's differentiate x squared. What would this be? Well, based on the power rule, we will need to bring the power down and subtract 1. Bring the power down, subtract 1. When we bring the power down, it would be 2. Then we will still have the x. And then the power is going to be 2 minus 1, which is 1. So the final answer is just going to be 2x. Okay. Let's try a few more examples. What's the derivative of x to the third power? And what's the derivative of x to the 10th power? So for the first example, we are going to be bringing the power down and subtracting 1. When we bring the power down, 3 becomes the number brought down, so that's 3. We'll still have the x, and then 3 minus 1, because we're going to subtract 1 from the power, is going to be 2. So it's 3x squared. This means that if we were to have a graph of x cubed, which would look something like this, and we want to find the gradient of the tangent at any point, let's say this point, we would just have to substitute the x coordinate, let's say this is a, we would just have to sub it into this expression right here. What about x to the 10th power? What's the derivative? Well, as you've guessed, we just have to bring the power down and subtract 1 from the power. So this is going to be equal to, when we bring the power down, that's going to be 10. We'll have the x, and then 10 minus 1 is 9. And that's our final answer. Okay, not too hard. Now, the power rule doesn't only apply to whole numbers. It can also apply to non-positive integers as well. So let's say we want to differentiate x to the power of half. And maybe we will also want to differentiate x to the power of negative 1/3. How should we go about this? Can we use the power rule? Well, yeah, because it's in the form of x to the n, where n is a constant and n is not equal to 0. Yeah. So therefore, we can still just take the power down and subtract 1. When we bring the power down, that's going to be half. X is still there. Half minus 1. This is going to be half. X to the negative half. If you wish, we can rewrite this into half times 1 over x to the half And x to the half is actually going to be equal to the square root of x, because if we have the nth root of x, this is equal to x to the 1 over n power. So we can actually just rewrite this whole thing into 1 over 2 square root x. However, usually this is fine. But if you would like to re-express your answer in terms of the square root, go ahead. You can also choose to rationalize this by multiplying the numerator and denominator by the square root of x. Okay, now to the next case. We have x to the negative 1/3 power. Can we use the power rule? Well, yeah, because we have the form x to the n, where n is a number, and in this case n is equal to negative 1/3. So as usual, bring the power down and subtract 1. When we bring the power down, we get negative 1/3. We still have the x. Negative 1/3 minus 1 is equal to negative 4/3. And that's our final answer. Next, we are moving on to the derivative of a constant. If we have the derivative with respect to x of k, where k is a constant, this is going to be 0. Why is this the case? Well, if we plot a graph of a constant, let's say y equals to k, where k is a constant, it would just be a straight line that is horizontal and it has a gradient of 0 throughout. Okay, so quick fire. What's the derivative of 3? Well, 3 is a constant, so that's 0. What's the derivative of 10? Well, it's still 0, because 10 is a constant. What's the derivative of pi? Well, pi is still a constant, it's 3.14-ish, so it's still 0. What is the derivative of pi squared? If you said 2 pi, that's wrong. Because you gotta remember, the power rule only applies when we have the form x to the n, where n is a constant. However, the base of this here is pi, which is a constant, and when we raise it to the second power, pi squared is still a constant. It's a known number. So it will never change in value when we change the value of x. So this is still 0. Alright, next we are moving on to the scalar multiple rule. This might be a little confusing at first, but don't worry. If we have the derivative with respect to x of k times f of x, where k is a constant, this is equal to k times the derivative of f of x. Okay, this is a bit strange. What do I mean? If I have, let's say, the derivative with respect to x of maybe like 4x squared, this is the same as 4 times the derivative of x squared, because 4 is being multiplied to x squared, and 4 is a constant. The derivative of x squared, just bring the power down, subtract 1, so it's going to be 4 times 2x to the 1 power, so this is 8x. Okay. Let's try a different example. Find the derivative with respect to x of 0.5 x to the fourth power. 0.5 is being multiplied to x to the fourth power, and 0.5 is a constant. So we can simply remove it from it. We can kind of like remove it from the derivative and multiply it separately. So this is 0.5 times x, the derivative of x to the fourth power with respect to x. Again, we are going to bring the power down and subtract 1. So this is going to be equal to 0.5 times 4x. 4 minus 1 is 3. 0.5 times 4, this is going to be equal to 2. You can think of it as 0.5 is half. We're going to multiply by 4. So this is equal to 4 over 2, which is equal to 2. We're not done yet though. We still have an x cubed. Don't forget to put it back. Nice. Okay. Next we have the addition and subtraction rule. If we have the derivative with respect to x of f of x plus minus g of x, this is equal to the derivative of with respect to x of f of x plus minus the derivative with respect to x of g of x. What this means is that if we have multiple terms that we want to differentiate, multiple terms being things separated by a plus or a minus, we can differentiate each term separately. What do I mean? Well, let's try to differentiate x squared plus 2x cubed. We see that we have x squared and 2x cubed being separated by a plus sign. So we can simply differentiate x cubed and x squared and 2x cubed and just add it together. So this is equal to the derivative with respect to x of x squared plus the derivative with respect to x of 2x cubed. The derivative with respect to x of x squared, simply just bring the power down minus 1. This is equal to 2x. For this other case, 2x cubed, we see that 2 is being multiplied to x cubed, and 2 is a constant that's being multiplied. So this is equal to 2 times the derivative with respect to x of x cubed. As usual, bring the power down minus 1. So this is 2x plus 2 times, bring the power down, so that's 3. X, 3 minus 1 is 2. So this is 2x plus 6x squared. If you wish, which is probably a good idea, factorize. So we see that 2x and 6x squared has a common factor of 2x. So we can just write 2x. 2x divided by 2x is 1. 6x squared divided by 2x is 3x. And that's our final answer. Now, one thing to note is that instead of having to do this intermediate working, we can actually already see it as we're going to bring the 3 power down and multiply it with the 2 directly. and then subtract 1. So this step is not necessary. We can actually just, if you are sharp enough and you are competent enough, you can actually just jump directly to this step. Now, let's try one final problem. Let's differentiate with respect to x, e plus 1 over 18 x to the 9th power minus the square root of x cubed. Okay, first things first, we have 3 separate terms, as you can see right here, that are separated by plus and minus signs. So we can just simply differentiate each of these separately. Next, we have an issue. We have a square root over here. We can't differentiate this directly yet. Using the power rule, we have to bring the power down to -1, but this is only for when it is in the form x to the n, where n is a known constant. Where x is a constant, sorry. So can we re-express the square root of x cubed into x to the n? Well, yeah. If we have the square root of a to the m, or maybe the nth root of a to the m, this is going to be a to the m over n. So in this case, it's going to be x to the m is going to be 3, so that is 3. N is, in this case, the square root, so it's 2. Okay. Now, let's get to differentiating. First things first, we see that e is a constant. It's about 2.7. So its derivative is just going to be equal to 0. The derivative of this, 1 over 18 x to the 9th, well, instead of trying to take out the scalar multiple and then differentiate it and then put it back, what we can do is simply bring the power down, multiply with it immediately, and subtract 1. Bring 9 down, -1. When we bring down the power, we are going to get 9 over 18, which is half. X to the power 9 minus 1, which is 8. Don't forget the minus sign. Remember that we are differentiating each term separately. Now we have x to the 3 over 2. As usual, bring the power down, -1. This is going to be 3 over 2. X to the 3 over 2 minus 1 is going to be half. And so this is just going to be half x to the 8 minus 3 over 2 x to the half. That's it. Thanks for watching, and I'll see you guys next time.